My name is Simon Lawrence. I'm from Bristol. I've been a developer now commercially for about 10 years, 5 years in Java and now about 5 years in Salesforce. And the company where I work at is only a small company. There's about 8 of us developers, but we're really passionate about testing because we don't ever want our projects to come back to us again once we've shipped them. So we spend a lot of time working on testing, and I thought I'd give a presentation today on some of the techniques we've developed to make better Apex tests. So, click somewhere. Oh, probably over here. All that. No, not going to get on. How do I get it? Technology, right? There we go, right. So, I'm going to start with a real quick overview, because there's a couple of things you have to cover off in any testing session. To explain very quickly why we test in Salesforce, we know to enforce the business rules and the logic that we've implemented for our customers or our clients, check the quality and consistency of work going forward. There's a really important one in the Salesforce world, which is to ensure that platform releases don't change our product. So every time they do Spring 16, Summer 16, Winter 17, they run all your tests to make sure that they're not going to break your stuff, which they're very, very good at. And also we have this criteria that we have to have test coverage to promote stuff in Salesforce from a sandbox to a live environment. We all know how to write quality tests, and I hope we all have a rough idea how to write quality tests, because I'm not going to cover this stuff too heavily. You have lots of system asserts. If we're doing triggers in Salesforce, we want to bulk test them, so you want to throw 200 records at them, because we all know that can happen in production when people do data loading and so on. You have to be able to handle it. We know that we have to set up our test scenarios accurately, and Salesforce have made it a lot easier these days with things like test setup and not using CO data and those kind of things. And the most important thing is not just aiming for that magic 75% mark in Salesforce. And you can't have a Salesforce testing presentation without saying 75%. Normally comes up about 10 times, but that's the only time I'm going to mention it. But we know that's what we got to do. With all those things in mind then, how often when we are working in our Salesforce orgs does something that looks like this, a fairly healthy little set of tests that you did in your sandbox 2 years ago, everything passed absolutely fine, suddenly turn into this when you come to make your next release, and you didn't run all tests on the production server because last time you made a release, all the tests passed. So on release day, you suddenly find out you've got a huge headache of trying to fix all your tests that are stuck in that production server. And this has happened to me over and over again, which is kind of what inspired this session. And so I started to think, why does this happen? What causes this to happen? And how can we stop it happening? Because I've had projects that have gone, 2 weeks late because there's been just some critically failing test in live. And I wanted to find out why it was. So I actually went on and I used the AskForce hashtag, picked up a few of our community colleagues to find out, and I'm sure you've all got reasons. If you give these a read, they probably all happen to most of you if you've ever made releases. Right up the top here, validation rules is an absolutely criminal thing. Admins and developers, admins creating validation rules straight in live, so all of a sudden your test classes can't insert the data that they're after. And the same goes to changing fields to be required. I was once in the middle of a release when the client was also in the org, and they literally made a field required on account sort of halfway through the release. So all of a sudden, all our test methods that were in certain accounts started complaining they couldn't insert their account with that certain field. It actually happens. Norman Wall said, yeah, validation rules the same. They also removed an app exchange product, which of course removed a bunch of custom objects or dependencies that it had, but their tests. We've got users being deactivated if you've written tests that will do run as, and then suddenly the user doesn't exist or the profile's been changed. CO data equals true. This is criminal. There's very, very few cases where CO data equals true is really a good thing to do, and it's going to cause awful problems. I had a scenario where we had a piece of work that we didn't do that depended on CO data, and then all of that data had been cleared out, and so the test didn't fail. And so one of my colleagues was like, well, why don't we just ask the client if we can insert 200 opportunities again with these values, and then our test will pass? It's like, well, probably because they got reports running on that data. I think that's a cool idea. We'll just get rid of the CO data and fix the tests. And then Alex here with quite a modern thing, the duplicate rules. And this has come up, and there's a whole bunch of tests that exist in orgs that I've seen. And I'm going to cover this off actually in one of my slides, where you'll insert 5 accounts, all put the same name in because it's just a test. Then they put a duplicate rule in saying that the account name has to be unique, and suddenly that test is going to start failing, and you're going to have a headache when you come to make release. To summarize those things, the problems we got is data model changes, such as validation rules, formula fields changing, that's going to break your test methods and so on. And then there's declarative logic changes, workflows. Now with things like flow and process builder, things that you can do straight in live are becoming more and more powerful. And they can interrupt the flow of your logic, and suddenly your tests aren't going to pass. Then you've got data and metadata dependencies that will change as people make changes to things like profiles and so on, and approval processes. And then sometimes stuff just gets old, like users being deactivated, or profiles being changed, or app exchange products expiring when you no longer pay for them. It's going to break your tests. So I'm going to go through 4 techniques here that we've developed at Design It by and large, and from interaction with the community on how we make sure that our tests stand a little better in the test of time. And even if they don't maybe always pass, for the next 10 years, at least they're easier to debug and fix. And that's one of the most crucial things, is knowing why a test is failing so that you can fix it really quickly. So the first thing I'm going to talk about is right at the very top of your test. And this is the thing that we call the 3-part test method name. So all of our test methods have 3 sections that are underscored. So we cover the unit that's under test, we then underscore, and then we have the conditions, and then we have the expected result. So instead of going for something like this, so if you've got test account deletion 1, test account deletion 2, and and then you go and make a release, if test account deletion 2 starts failing, you're not going to have a clue what's really happened until you start digging into the text. You've got to go through the test method. You're probably going to. Whereas if your methods were named something like this, so the unit of code being tested would be confirm delete. You got your conditions, such as whether a checkbox is ticked or not, which might be a criteria for deleting something. And then what's going to happen here at the end, when this fails and you see it in the developer console, you see it in your test execution harness, you already know where you're probably going to start looking. If this one's failed, and your assert has come up saying that there's no account, you probably already know that something's happened, with this checkbox that's meant that that's been deleted. You've got some idea going in. This also makes it really easy to write more and better unit tests, because it makes you think about all the different conditions that you're going to have. So rather than just going 1, 2, 3, I've got 4 test methods, that's probably really well covered. You can see, and your peers reviewing your code can see what you've actually thought about, and it will make you write better unit tests, and you'll get better coverage for that, and it'll help you work those things out. So all of our tests always look like that, and if people go back to anything like this, then they get a scolding. The second tip that I give you, and this is actually something I was just doing at the start of this week, was repairing some tests, is asserting your preconditions. Now we all know to fill our tests with loads of system.asserts at the end, make sure that all the data's there that you want in the shape that you want it. But if you had a test that looked a bit like this, which is just taking a bunch of accounts, and then we have some sort of service class here that does a bunch of stuff, and then at the end of it, we're asserting that we've got 50 accounts, when we've gone through probably an insert of 200 here. If this started failing in your org, you'd probably go, oh, right, well, clear zombies has gone wrong here. So you go delving into clear zombies, you go, why aren't we getting 50? Are we getting 100 instead? Or it's not clearing enough out. If you're getting 0, you're like, why is clear zombies removing all of my accounts? But the truth is, this assertion 50 here, from here, is actually already been through an insertion. And it's also been through this generated accounts utility that you've written. So by the time you actually get here, loads of stuff could already have happened. If there's a trigger or a validation rule that might have stopped the inserts happening properly, or someone's come in and fiddled with generate accounts because they thought, oh, I actually want twice as many accounts as that parameter, so we'll do it times 2, that everything's gone wrong. You don't know. One really quick, simple line to just do an assertion there, it's totally valid testing, will mean that you've now isolated either a failure here, or a failure here tells you that your actual test bit is going wrong. If your test fails and says it's this line number, 200, you go, right, well, someone's broken our utilities, or our insert isn't happening. You know this is all right though. Well, you don't know it's not got there, but you know it's not there, so you don't have to go wasting time looking at your clear zombies method. And likewise, if it's this one failed, you know the stuff above has worked. So it's a really handy way of just circle your test code in assertions. The more the merrier, because it's a great way of tallying if something hasn't happened that you've expected. My third tip is for only testing the code you need. Now, everyone knows about unit testing and then integration testing, end-to-end testing, all that kind of stuff. But it's really hard to kind of focus in sometimes, especially with Salesforce, on just a single unit of code. So here's a really simple method, total account levels. Takes a list of accounts, set up an integer, whip through them, add them all up, and then return the number. Seems like it should be easy to test. So here is what you might consider to be a fairly decent test situation for this. We've got a utility method up here, and we've got a test method down here. We come in, we've got totally account levels for multiple levels, and the warning is summarize, so you know what that's doing. We call insert accounts, which is probably a really useful thing. So up it whips. We create a list. We put in however many accounts that we put in bulk size. That's fine. That'll be a static somewhere. We've actually got a floor here, which I mentioned earlier. We then set up some accounts with a warning level and insert them all. Seems good. But actually, if there's a duplicate rule on account, that there is actually going to fail straight out of the box. So you're going to get some problems. You really should have like +i there or something, right, to make them unique. But either way, that inserts, comes back here, calls our method, sticks the list in, and asserts that that's all totaled up. But again, you're running through a lot more stuff than you necessarily need here. If we go back and look at the code a second, oh, I know, all right, that's the bit that's going to cause a problem. If we go back and look at the code a second, we take the list of accounts and we add up the warning level. All we actually need to know about these accounts is their warning level. So if you have triggers and workflow that are fiddling with accounts and they're doing all sorts of other complicated things, that test method doesn't necessarily need to worry about that. It just needs to know, with this list of accounts, return the right result. So I could turn that test method, which also was a lot bigger, into something much simpler like this, and you can see I've removed the insertion. We don't need to insert those accounts. That unit of code is only interested in totaling up those warning levels. So when you're doing your things, look at what you're testing and think about it. We don't want to test triggers here. We don't want to test workflows. We don't want to test what happens to accounts when they're inserted or when they're selected. We just want to know with a list of accounts what's the total result. I think that's all of that, was it? Yep, so there we go. Could you put any precondition assertions in there? Probably if I thought about it. Okay, I will whip through those because now I'm coming up to number 4, which is a slightly bigger one, so I'd spend a bit more time on this. And before I do, in fact, I've been asked to point out that there's another session, actually, which covers true unit tests with Apex mocks. It's at 2:45 by Dan Flood up in the control room. He's actually going to cover mocking really, really well. So I'm kind of going to go through how we use it and design it. But when I went through this session with the organisers, they said, you do know the guy that wrote Apex mocks, or I think his colleague is actually presenting on it. So go see that one as well. But this is something we do to kind of bring a lot of those things together. We use interfaces to kind of mock away what we call heavy lifting. So we're only testing the bits that we want at the time that we want to test it. So if we had some really heavy lifting, which was happening to accounts when you clicked a button on a page, and you wanted to test all that, you'd write some really good unit tests that tested all that heavy lifting. Maybe it's making web service callouts, maybe it's doing really complicated Apex, but you know, that's going to have good tests on it. If you then had a button on a page that kind of called that and did some other things, you don't necessarily want to make the test for that button go through that whole process, partly because if you've got web services, you're going to get involved in doing HTTP mocks and so on. So with the help of the Apex mock guys, and there's another slide at the end of here that has a couple of blog posts that's really good reading on this stuff, we kind of developed this little process that we use. So anything that has some heavy work in, we'll put in a service class. That's just good separation of concerns. But what we do is we'll base the service classes on an interface. So we're using like inheritance stuff. So we have the interface and we're going to implement that. So if we had an account management service, this would be our interface. And then what we could do is we would write an implementation of it, account management implementation. It extends it, so you're going to have to implement that method. And then this is where the really heavy stuff goes. So we do all our web service callouts and all the other stuff that we might want to do. And that's the real work. That will have its own unit tests that you'll write up, and it will be covered off. Then if you had a button on a page that was calling that calling that really heavy lifting, call the button save accounts. These are the only 2 lines here. You know, so if we're thinking about what we want to test, if we were trying to test that save accounts method, we would just want to make sure that really heavy lifting had been called. We don't necessarily want to test its specific return because that's been tested elsewhere. So make this unit test, just test save accounts. Because one of the reasons for this is if really heavy lifting did change and it broke its own unit test, you just want its unit test to break. You don't want this test to start failing because that's changed. You want this one to kind of pass because it's still doing what it was told to do, call really heavy lifting. That one has its own. So to achieve that, what we do is you create 2 constructors for the classes that use that interface. So you have your public no argument one or public one argument one, the standard one. Leave that as it is in there. But what you want to do is create yourself a private second constructor. And this is one of the very few times that I've actually seen the test visible flag used really well, because we make this private, so only this class can kind of call it. But then by making it test visible, as you'll see it on the next slide, we're going to be able to access it, but just from our test method. But we have the public one, and we just use that to call the private one with a new version of the actual implementation. So account manager impl, we don't need to really do anything particularly clever there. And then when we pass that in here, it comes into this private one, which takes one of these. We set it up as an instance in the class, and then when we call our save method, which I'll pop back, you'll just see that we just call actman.reallyheavylifting, and in the natural flow of Salesforce on the Visualforce page or whatever structure of classes you've got, it will just seamlessly be calling the real heavy lifting. However, what we can then do for testing is write another one of these implementations, account management mock rather than impler, and that extends the same interface. So we're forced again to implement our really heavy lifting. But here you can build up exactly what you want. And quite often, instead of doing all sorts of web services and all that kind of stuff, it could just be 2 or 3 lines. You could just say return 9, return 10. You could base it on the parameters because you know you're going to get what you told it to pass in. So you could do different things. Sometimes I pass in different lengths of list. I'd be like, oh, in my test I set up exactly 2 accounts. If you get exactly 2 accounts, return a certain thing. If I want to test another scenario, just stick another account in that list, and then you can determine here, what you want to do. And the Apex Mock thing has a really clever way of actually managing the returns. But basically, this is now, a mock in front of that really heavy lifting. So on our test class, we have this test method. We're telling it what we want to do, save accounts finalized. There we go. It's a nice 3-part name. We've got a utility method there, shoves an account in. And then when we instantiate our controller, we're calling the private one that was test visible. So what we can do is we can kind of override or stuff in one of our mocks. So if we'd called the public one argument constructor, that would have made a real one with all the heavy lifting. We haven't. We said use the other one, and that gives us our mock. So then when we call ACM saved account in the test, we're just getting back exactly what we told it to. So this is a great way of just cutting out all that really heavy lifting that should be tested elsewhere. It makes the save accounts unit only test those couple of lines of code, but it makes it test it really well. And it will save you from going through all that code that you might not necessarily need to test just to test that little bit there. This is a really good way of breaking things down into little chunks. Wow, I've absolutely rattled through that, haven't I? I'm afraid I talked it like 1,000 miles an hour, because that is the last slide. These are 2 of the blog posts that last technique is based on. Alex Tennant, as a guy I work with, has actually written this up, and it will take you more than 16 minutes to read it, so that will probably be better than this. And then dependency injection in Apex, which is kind of what that's about, by overloading the constructors, was done by Jesse Altman. Is another really good thing. All these slides will go online and everything, so I'm sure you can get them there. But you know, photograph them. I'll kill a minute. Keep going. Autographs. So yeah, has everyone got that down, or they can find them online afterwards? And yeah, just like that, I must have been pumped up from dinner. That is the end. Thank you. If you have questions, you can find me on Twitter. I'm SRLAWR, and that is my picture, just so you can find me, because there's a few of us. And then I work for Designer, like I said, an IT consultancy over in Bristol. We love community stuff. We run a user group, or 2 user groups in Bristol, the normal user group and the developer user group, which I run. We're meeting next Thursday. I've got to provide a presentation for that as well. So if you're ever over in the Southwest, you can come see us at the groups, or just like drop us tweets or lines or whatever. We'll answer questions on Stack Exchange and so on. Does anyone have any questions on that whistle-stop tour of writing sustainable and maintainable Apex tests?